You are welcome once again to Physics Medicine online tutorial class. Today we want to look at the applications of viscosity. But before then, in our previous class, remember we defined viscosity. And how did we define viscosity? We defined viscosity as the frictional force between the adjacent layers of the fluid as they move past one another. So we say that the same way friction occurs in solid, that friction equally occurs in fluids. And when we talk about fluid, we talk about both liquid and gas. And remember we said that in liquid, viscosity is due to what? Cohesion, force of cohesion between the liquid molecules. Whereas in gases, we say that viscosity occurs as a result of what? Collision between the gas molecules. Equally, remember that we talked about the effects of temperature on viscosity. We said that in liquid, that increasing temperature tends to decrease what? The viscosity of a liquid. While in gas, increasing temperature increases the viscosity of what? Liquid. Then we equally talked about terminal velocity. We saw the equation on how we achieve terminal velocity. We equally use the motion of a stone in a viscous liquid, whereby we have three forces that are acting on the stone that is dropped inside a viscous liquid like your glycerin. We have the weight of the stone acting downward. We have the obtruse force acting upward, and we equally have the viscous force, or you call it the viscous drag, acting equally upward. We say we achieve the terminal velocity when this obtruse and viscous force balances the weight of the stone. In such a case, that the velocity or the speed of the stone remains constant. We say we have achieved what? Terminal velocity. Now, today we want to briefly look at the applications of this viscosity. Where do we apply viscosity? Now, let's see our specific objectives. By the end of the lesson, students will be able to, number one, you'll be able to state the applications of viscosity. Number two, explain the applications of this viscosity. And number three, state the differences and the similarities between viscosity and what? Solid friction. Now let's see where we apply this viscosity. Applications of viscosity. Number one, we find out that liquid with high viscosity, such as your engine and grease, we use them as what? Lubricants in machinery with moving parts. And the molecules of the liquid, they tend to stay together due to what? The strong cohesive what? Force. Now this leads to the formation of a layer of the liquid between the metal surface of the moving what? Parts, which helps to keep the surface from rubbing against each other. So you find out that all these lubricants, our engine oil, lubricating oil, our grease, they are viscous what? Liquid. And we use them as our lubricants, rubbing them at the surface of the moving parts of our machinery in order to reduce what? Friction, so that the moving parts will not rub against each other. So this is the one of the application of what? Viscosity. Now, we equally apply it in the case of a parachute. A parachute uses this viscous drag or force exerted by the air on a free falling person to slow down his descent and cushion his fall, thus protecting him from what? Injury. Protecting him from what? Injury. Now you find out that a parachute serves as a save for a person that is falling freely under the influence of gravity, or somebody that is falling from the sky or from an aeroplane. The parachute serves as a guard to protect that person from what? Injury, or from hurting him or herself. So this parachute is just like a cloth or canopy that fills the air and allows a person or a heavy object that is attached to it to descend slowly when the object is dropped from the sky or from aircraft, to avoid injury or to avoid a person wounding his or herself. Now, a skydiver is in a free fall. The force of gravity, when a skydiver is in free fall, the force of gravity acting on him will be greater than the drag force of air resistance. So when somebody is falling freely from air, for example a skydiver, you find out that the force of gravity that is acting on that skydiver will be greater than the viscous drag. And remember, we said that for us to attain terminal velocity, that this viscous drag must balance the weight of the body. So in this case now, causing the person to accelerate downward. Now as this acceleration increases, the drag force does increases. So as the speed of the person is increasing, as the person is accelerating, the viscous force or the viscous drag equally does increases, as we saw in our previous class, and eventually it equals the force of gravity. Now the velocity of the skydiver is not constant in this case. The terminal velocity achieved by the skydiver is high. And when the skydiver did not achieve a terminal velocity, on landing, the skydiver will wound him or herself. Now, and he would be seriously hurt if he landed at that speed, whereby the terminal velocity is high. Now when he opens his parachutes in the air, what happens? It greatly increases the drag force in the skydiver and causes him to slow down. So these parachutes will increase the viscous drag on the skydiver, and it will now cause the skydiver to do to slow down. Now as his acceleration decreases, so does the drag force, until eventually is equal to the force of gravity. So as the skydiver, the speed decreases, that means the acceleration is doing decreasing. And as the acceleration decreases, the drag force or the viscous drag will equally do decrease, until the viscous drag is equal to the force of gravity that is pulling the skydiver down. So in this case, the velocity is now constant. So the skydiver has reached terminal velocity. So his terminal velocity is significantly lower than that achieved during the free fall, so that the skydiver can land safely at this terminal velocity. So we apply this terminal velocity using our parachute. The parachute serves as a safeguard when a skydiver is landing from the sky. So this parachute become a safe guard, so that the skydiver will not injure himself or herself. We have other applications of viscosity. We apply them in transparent and storing facilities for fluids, Example, your pipes and your tank. So it is this viscous force, viscous liquid, they are used in making our pipes. Another one, bitumen that are used for road construction. You see these bitumen that are used when they are tarring the road, they are equally viscous what? Fluid. They are viscous liquid. So we use these bitumen that are viscous liquid in during our road what? Construction. Another application is in designing of the sewer line or any other pipe flow. Viscosity play an important role in finding out its flow behavior. So in designing our sewer line or designing our pipeline, viscous material are being used. Another application, drilling for oil and gas requires sensitive what? Viscosity. When we are drilling, we are drilling for oil and gas, viscosity is needed. Now another application is to maintain the performance of machines and automobile, as we have said before, by using of our lubricating what? Oil. So these are the applications of what? Viscosity. These are the applications of what? Viscosity. Now we look at the similarities and the differences between solid friction and what? Liquid what? Friction. Similarities between solid friction and liquid what? Friction. Now the similarities between the solid friction and liquid friction, what do they have in common? Remember in your first term you talked about solid friction, whereby you have the laws that are governing solid what? Frictions. We want to compare the two friction now. Whereas now we are talking about viscosity, that is the friction that occurs in fluids, that is liquid and what? Gas. Number one, similarities, the things they have in common. Both forces they oppose relative motion between what? Surfaces. Now when you talk about solid friction, you find out that the two bodies in contact, there is a force of opposition between the two bodies that are in contact. The same thing in your fluids, both your liquid and gas. There is opposition between the molecules as they tend to move over what? Another. The molecules they tend to oppose themselves. Another one, both depend on the nature of the materials in contact. Now remember, for your solid friction, one of the laws of solid friction is that it depends on the nature of material in contact. Whereas we say that when you have for a smooth object, when you have smooth surfaces, in smooth surfaces you encounter less what? Friction. Whereas in rough surfaces you encounter more frictional force. Now the same thing here in viscosity, you find out that when the liquid is more viscous, you encounter more frictional force. For example, in your engine oil, if you're dropping a sphere like a stone in your viscous liquid like your engine oil, the stone encounters more viscosity. The viscous drag increases, unlike when you're using water or kerosene, which has less what? Viscosity. So both the solid friction and liquid friction, they depends on the nature of the surface, the nature of the material in contact. Now we look at the differences between the solid and liquid friction. You can see that in a tabular form. You have your solid friction and your liquid what? Friction. Number one difference, please take notes. Number one, they does not depend on area of surfaces in contact. Solid friction does not depend on area of what? Surfaces in contact. This is one of the laws of solid friction. While for liquid friction, they depend on area of surface or layer in contact. So you find out that for your liquid friction, which is viscosity, it depends on the area of surface or the area of what? Layers in contact. More viscous bodies experiences more viscosity than less viscous material. But for your solid friction, despite the area of the solid, it must encounter frictional force. Whether the area of the solid is high or whether the area is low, that body must encounter frictional force. Now, number 2, it depends on normal reaction. This is another law, one of the laws of solid friction. Remember, for solid friction, we say that it depends on what? Normal reaction. When you have the solid friction for an object in a horizontal table, or the object is inclined, you find out that for solid friction, the forces that are acting on it, number 1 is the weight of that object acting downward. Then number 2 is the upward force, which we call the normal reaction. And then you have other forces, applied force, you have your frictional force. And we say that when the weight of the body increases, the applied force and the frictional force increases, and equally the normal reaction will do what? Increase. And that is where we got our formula for calculating for solid friction, where we say that frictional force F is proportional to normal reaction. And when we remove the proportionality sign, we introduce a constant which we call the coefficient of friction. If you're talking about static friction, mu, we call it coefficient of static friction. If we are talking about dynamic or limiting friction, we call it coefficient of dynamic friction. So for solid friction, we say that F is equals to mu R, where R is the normal reaction. But in this our liquid friction, there is nothing like normal reaction there when we are talking about viscosity. So liquid friction does not depend on normal reaction. Now we go over to the next one, number 3. Solid friction, they are otherwise called what? Dry friction. So solid friction, we can call them dry friction, while liquid friction can be called what? Viscosity. It can be called what? Viscosity. Now, finally, for solid friction, it does not depend on the relative velocities between surfaces in contact. What do we mean by this? This is another law of solid friction. It does not depend on relative velocity between surfaces in contact. When you are talking about relative motion, two bodies must be involved, and those two bodies involved, they must be in contact. Now, for example, let's take it this way. If you have a vehicle that is moving on the road, remember the vehicle encounters frictional force as it moves on the road. Now, if the velocity of that vehicle or the speed of the vehicle is high, as the vehicle is moving on the road, the vehicle encounters frictional force. Now, if the speed of the vehicle is low, probably maybe 10 meters per second, the vehicle is moving 10 meters in 1 second, you find out that that vehicle will still encounter frictional force. And if the velocity is 100 meters per second, it will still encounter frictional force. So for solid friction, it does not depend on the relative velocity between the surfaces in contact. But in liquid friction, it depends on the relative velocity between what? Layers. Remember when we talked about viscosity, we said if you're using your glycerin and you're using what? Water, and you drop a sphere or a stone inside it, and when you drop the stone inside the water, it moves to the bottom of the beaker very fast. The speed, the velocity will be fast than when you drop it inside the what? Glycerin. or your lubricating in or your engine oil. When you drop it inside the engine oil, the speed of or the velocity of the stone will be what? Slow. So you find out that in your viscosity, it depends on the relative velocities between the layers, whereas in your solid friction, it does not depend on the what? On the relative velocity between surfaces that are in contact. Now, in our next class, we are going to look at units used in industries. We are going to look at units that are used in what? Industries. Remember, in your first term, we've talked about the SI unit, which is one of the important things. System International what? Unit, which is the acceptable unit we use in physics. But this time around, we are going to see other units that can be used in the industries that are not the SI unit. Now let's see our assignment. Now you look at the assignment number 1. State 2 applications of viscosity. Number 2, explain one of the above mentioned application. So when you state 2 of them, any 2 among the applications we have listed, you explain one of them. Number 3, state 2 differences and 1 similarity between solid and liquid friction. Please take note of this number 3 question. It has been asked severally in WAEC. Another assignment number 4, a ball when dropped from a boat into a lake will eventually achieve what? Terminal velocity. Sketch a graph to show how the velocity of the ball changes with time. So sketch a graph to indicate terminal velocity. We have said it in our previous lesson. And remember, it is because of this terminal velocity that is why when rain falls, the speed of the rain that is coming from the sky will not hit us with that particular speed, because if the rain hits us with the speed from which it is coming from the sky, we are going to sustain what? Injuries. But as the speed increases, a time will come when it will reach terminal velocity before dropping on us. That is why the rain will drop on us without us sustaining what? Injury. Another one, use the graph you have sketched in above to explain how terminal velocity is reached. So use that graph to explain what? How terminal velocity is reached. So you explain the graph you have drawn. You are going to explain the graph. Now, thank you once again for your patient listening. I remain your teacher, Mrs. Okuma I. We are going to see you in our next class.